We're solving problem 13 from the 2025 Amy 1. Alex divides a disk into 4 quadrants with 2 perpendicular diameters intersecting at the center of the disk. He draws 25 more line segments through the disk, drawing each segment by selecting 2 points at random on the perimeter of the disk in different quadrants and connecting these 2 points. Find the expected number of regions into which these 25 line segments divide the disk. So, we have a disk, right? Let's just do a circle. And then we have a horizontal diameter and a vertical diameter. Now, note that there is an intersection. There's one intersection because it's the center. So these 2 diameters intersect and make 1. Now, we realize that for this problem, we have to make a really basic insight. If you have a line and it doesn't intersect any of these 2 diameters or older lines, then you have one new segment or one new section. If you have a line that intersects at one point, it creates 2 new regions, and then if you have a line that intersects at 2 different points on 2 different old lines, then it creates 3 new regions. So in general, we will say that the number of new regions created is equal to number of crossings between lines plus 1. Now the way we can do this is, since things aren't guaranteed, we want to find the expected number of regions. Hint word expected. Now, there's no way to tell where Alex is going to draw all the 27 or 25 line segments. So we have to calculate the average or the probability that these things will happen. So eventually, find the average or the expected number of regions. So first, what we can do is we can calculate if the line goes through the horizontal diameter or the vertical diameter. Now, the horizontal diameter has 2/3 probability of being crossed, and then same as the vertical, also has 2/3 probability to be crossed. So 2/3 plus 2/3, it's 4/3. And now that's what we have. So we now just multiply this by 25 since there's 25 line segments. Gives us 100 over 3. Now, if we have 2 lines intersecting, that also creates a new region. Now, we find that through various means that the probability of 2 lines intersecting is going to be 17 over 36. Then we want to find how much. So, how much intersect or go through each other. So, we have, to calculate that, 25 of the new times 24 over 2 is equal to 300. So we have our number, 300 times the probability, 17 over 36 equals 425 over 3. And then what we do is we sum these 2 numbers, because these are the 2 kind of cases we considered. So 1 plus 100 over 3 plus 425 over 3 equals 176. Then we have to consider the region already made, and then we have to consider, we just add 1 here because that's just what is telling us, because we found out that earlier. So we have to add the 27 new regions made by the line segments to this, and then slap a 1 on it. So 1 plus 27 plus 176 is our answer of 204, and we are done.